Concept 38, vectors. It says find the vector represented by the diagram. So when they say find that, we need to find its, basically its coordinates of that vector. So we need to know how far it's going in the horizontal direction and how far it's going in the vertical direction to find its coordinates. So let's just kind of complete the triangle here. And we need to be able to find that x and that y in that diagram, knowing that this is a right triangle. So any ideas?
8 times sine of 4.
To find what?
Yeah.
To find what?
Find
the other.
So to find the y value, we want to use the sine function.
yeah.
So we know that the sine of 14 degrees would equal y opposite over 8 hypotenuse. And y would turn out to be 8 times sine of 14 degrees. Which, when I did the calculation, was approximately 1.94. How are we going to find x?
1.9 divided by tangent.
I like the idea to use the cosine. We could use tangent, but if we use tangent, we're going to use this calculated rounded value. I would rather use the cosine and use the given whole value there. So cosine of 14 degrees is equal to adjacent, which would be x, over hypotenuse, which would be 8. So x is equal to 8 times the cosine of 14 degrees, which is approximately 7.76. But notice that both these values are kind of negative values. Not kind of, they are negative values. The x is going to the left, right? That's usually a negative value. And the y is going down, that's a negative value. So our final answer needs to represent that direction. We're going left, 7.76, and we're going down approximately 1.94. Now if you rounded this off to the 10th, that's okay, because it didn't say where to round. But thanks. We ought to have the negative there on the 1.94. So our final answer would be somewhere in that range, negative 7.76, comma, negative 1.94. Questions on number 2?
You're saying you didn't realize the question on the test was a problem?
Yeah, I didn't see number 2. I saw the 3.
Number 9, we're asked to just add the vectors. So if we add the x coordinate to the vectors, we have 1 and negative 5 is just negative 4. And if we add the y coordinates to the vectors, we have 9 and negative 7 is 2. And that's all we needed to do on that one. We're done. So we get the vector negative 4, comma 2. Questions on that one? All right, let's keep moving.
All you do is add the vector.
Number 4, compass directions. All it says is write compass directions for this diagram. Who's got that?
I got that.
35 degrees. We're trying to go north, but we're falling to the east. So it's east of north. That would be the correct answer. Questions there?
I think number 6 shouldn't count because that was more understanding.
Okay, next one was number 5. 5 and 6, transformations. Concept 40. This number 5 took a little bit of effort. We have to find the image of O, which is at negative 1, 2, after 2 reflections, first in the line y equals negative 3, and then in the line x equals 5. So let's kind of just, we don't have to actually graph it, but let's at least sketch where this would be. So negative 1, 2 would go left 1 and up 2. Agreed? Okay, so it's right here. Now we need to reflect that in the line y equals negative 3. So that's going to be somewhere down here. So it's going to go across that line. We need to know how far this is so we can reflect it across there. How far is that distance going to be? it's up at 2, and we're going across negative 3. So we're going to go 5 the other side of negative 3, which would put us where? Negative 8. So we're going to be all the way down here. Is the x value going to change, the negative 1? Now we're going to be down here at negative 1 comma negative 8. So that's the first reflection in the line y equals negative 3. Now we're going to take this point where we're at now and reflect that in the line x equals 5. Well, x equals 5 is going to be somewhere about over here. So what distance do we need to figure out now? So we know how to reflect that. We just on the first reflection we had to figure out how far down we were reflecting so we could take it across. How far? Which way? Over? So how far is it from the point to this line x equals 5? 6. So if we go the 6 the other side of 5, where are we going to be? We're going to be at positive 11. And what's the y value going to be here? Negative 8. So that should be our answer for number 5, is that point would end up at 11, negative 8. And if we want to show that it's the image, we can do the O prime. Questions on that? Nope. Number 6 we'll do down here. It says, describe in words the translation represented by the vector 4, comma 2. A few guys got this right. What do we need to say? It actually goes right 4 and up 2. Yeah, it's just telling us how to move. Right 4 and up 2. So you'll get that one next time, right? The last couple are multiple choice questions. They're both on the concept of symmetry. It says, identify the choice that best completes the statement or answers the question. So we're trying to figure out the kind of symmetry we have here in number 7. Is it reflectional, rotational, rotational and reflectional, or does it have no symmetry? It's just rotational. We can rotate it how far? 180 degrees. It won't reflect because it won't be the same, right? So we can get rid of anything that says reflectional, and we do see the rotational, so we don't need the other one. Number 8 says, tell whether the three-dimensional object has rotational symmetry about a line and or reflectional symmetry in the plane. What did you guys come up with? Just reflectional. Yeah, we just basically cut it in half and see the same shape. And that was it for the exam.